In 2015, a NASA discovery captured the attention of the entire world. After analyzing thousands of distant stars, astronomers announced a planet with a truly striking set of characteristics. It orbited a star similar to our Sun, completed one full orbit in almost exactly the time it takes Earth to complete a year, and sat right within the so-called habitable zone, the region where temperatures could allow liquid water to exist on the surface. For the first time, it seemed humanity had found a world that genuinely resembled our own in nearly every respect. But there's one detail that turns this story into one of the biggest mysteries in modern astronomy. The more scientists study this planet, the more they suspect it might not be a new Earth at all. In fact, it may represent our own planet's future, a world billions of years older, one that underwent a completely different evolution, and one that may have already become something far removed from the paradise we like to imagine. Does this planet still have oceans? Is its atmosphere still favorable to life? Or has it already turned into an unbearably hot, uninhabitable place, showing us exactly what could happen to Earth billions of years from now? Well, let's find out why Kepler 452b is one of the most fascinating exoplanets ever discovered. Before we head off to visit one of the most promising exoplanets we know of, hit subscribe and turn on notifications so you don't miss anything. And don't forget to like the video and drop your thoughts or video suggestions in the comments. For thousands of years, humanity has looked up at the sky wondering whether other worlds like Earth exist out there. But there was a nearly impossible obstacle standing in the way. Planets don't emit their own light. They're small, dark, and completely drowned out by the intense glare of their host stars. It's like trying to spot a single grain of sand orbiting a lighthouse from thousands of kilometers away. For a long time, finding a planet outside our solar system seemed like an impossible task. To change that, NASA launched the Kepler Space Telescope in 2009. Contrary to what many people assume, its mission wasn't to photograph planets directly. Instead, it spent years continuously monitoring more than 150,000 stars, watching for nearly imperceptible dips in their brightness. The strategy was remarkably clever. If a planet passed directly between its star and the telescope, it would block a tiny fraction of that star's light for a brief moment. That dip was so subtle that, in many cases, it amounted to less than 1/100th of 1% of the star's total brightness. Even so, sufficiently sensitive instruments could still register that tiny variation. But even catching a single dip in brightness wasn't enough on its own. It could have been caused by any number of natural phenomena, or even by an observational error. Scientists needed to find a pattern. When that dimming happened repeatedly, always at the same interval and with nearly identical intensity, it became strong evidence that a planet was completing its orbit again and again. It was like watching the shadow of an object regularly passing in front of a distant lamp. Even without seeing the object itself, its existence could be proven. That's exactly what happened with a star located in the constellation Cygnus. After years of collecting data, Kepler revealed a planet completing one orbit around that star in roughly 385 days, a period remarkably close to an Earth year. What's more, that orbit placed it right within the habitable zone, the region where temperatures could allow liquid water to exist on the surface. In July 2015, NASA officially announced the discovery of Kepler 452b, an exoplanet that quickly became known around the world as the best candidate yet for a second Earth. But discovering it was only the first step. The much harder question that followed was whether the planet was as promising as the star illuminating this distant world. When we think about a habitable planet, it's natural to focus all our attention on the planet itself. After all, planets are what could host oceans, mountains, and perhaps some form of life. But there's a crucial detail that often gets overlooked. A planet's fate is determined largely by its star. The star controls temperature, climate, atmosphere, and even the possibility of liquid water existing at all. And in the case of Kepler 452b, its star might be exactly the piece that makes this story even more fascinating. The star is named Kepler 452 and belongs to the same class as our Sun, a yellow dwarf of spectral type G, meaning it produces light very similar to what illuminates Earth every day. If an observer could stand on the surface of a planet orbiting it, they'd likely see a familiar sky bathed in golden light much like our own. That resemblance is exactly what drew scientists to see enormous potential in this system. But look a little closer and you find some important differences. The star has roughly 10% more mass than our Sun and is estimated to be around 6 billion years old, compared to the Sun's roughly 4.6 billion years. In other words, Kepler 452 is an older version of our Sun, a star further along its long evolutionary journey, and that completely changes how we should think about Kepler 452b. Like all Sun-like stars, its brightness slowly increases over billions of years. That change is nearly imperceptible on human timescales, but enormous on a cosmic one. Billions of years ago, Kepler 452 emitted less energy than it does today. That means, in the past, its planet likely received an amount of heat much closer to what Earth receives right now. If oceans, rivers, or conditions favorable to the emergence of life ever existed there, that distant era may well have been the moment. Today, though, the situation could be quite different. With its star emitting more and more energy over time, KEPLER 452b may be entering a gradual warming phase. If it has an Earth-like atmosphere, it could be experiencing an increasingly intense greenhouse effect, slowly raising its temperature and profoundly reshaping its environment. Some researchers even believe this planet could represent a kind of future version of Earth, a preview of what our own world might look like billions of years from now once our sun also grows brighter. It's a striking idea. By studying a planet more than 100 light years away, humanity might actually be observing a preview of Earth's own eventual fate. But that brings us to the most important question of all. What does KEPLER 452b actually look like? Does it still resemble our planet, or is its true appearance completely different from what we imagine? After discovering a planet orbiting a sun-like star inside the habitable zone, with a year almost identical to Earth's, the next question became unavoidable. Does KEPLER 452b still resemble Earth? Is there a rocky surface covered in oceans and continents, or is everything we imagine simply an illusion created by the enormous distance separating us from this world? The first piece of information astronomers were able to pin down was its size. KEPLER 452b has a radius roughly 60% larger than Earth's, placing it in the category known as super-Earths. That name might suggest a planet just like ours, only bigger, but the reality is far more complex. Super-Earth is purely a size classification. It doesn't tell us what the planet is actually made of. It could be predominantly rocky like Earth, but it could just as easily have an entirely different composition, with enormous amounts of water, ice, or a thick layer of gas surrounding its core. Even without knowing its exact mass, many models suggest KEPLER 452b has a strong chance of being a rocky planet. If that's correct, its gravity would likely be stronger than Earth's. A person walking on its surface would feel noticeably heavier, needing much more effort for simple tasks like running or jumping. Still, that extra gravity could also help the planet hold onto a dense atmosphere for billions of years, shielding its surface from space radiation and helping stabilize its climate. Another curious detail is that its year lasts about 385 Earth days, only about 20 days longer than ours. That means that if KEPLER 452b has seasons, they might not be all that different from the ones we know. Its position in the habitable zone also makes it plausible to imagine a world where liquid water could exist, forming rivers, lakes, and oceans. But it's important to remember this is still only a possibility. Everything we know has been derived from analyzing the extremely subtle light of its star. And that's exactly where imagination meets science. Some researchers believe KEPLER 452b could have vast continents, towering mountain ranges, and deep oceans shaped over billions of years. Others suggest its stronger gravity could fuel intense geological activity, with more numerous volcanoes and an interior even hotter than Earth's. There's also the possibility that a thick atmosphere could drive a much stronger greenhouse effect, completely transforming its climate. The truth is, for now, no one knows which of these scenarios is correct. KEPLER 452b remains hidden behind the enormous distance separating it from humanity, revealing only small clues about its true nature. But there's an even more important question than what it looks like. If this planet really does share so many characteristics with Earth, could it actually support life? That possibility is exactly what makes it one of the most fascinating worlds humanity has ever discovered. Ever since KEPLER 452b was announced to the world, it's been impossible not to ask, could there be life on this exoplanet? It's a fascinating question, but the answer demands caution. The truth is that so far, we obviously haven't found any evidence of living organisms on KEPLER 452b. All we know is that it satisfies some conditions that could, in theory, make life possible. And that alone is enough to place it among the most promising exoplanets ever found. The main reason for that interest is its position relative to its star. As we've seen, KEPLER 452b orbits within the habitable zone, the region where temperatures could allow liquid water to exist on the surface. That detail matters enormously because, as far as we know, every known form of life depends on liquid water. However, sitting in the habitable zone doesn't automatically make a planet habitable. Mars, for instance, was once in a far more favorable position than it is today, and it still ended up losing most of its atmosphere. Venus, on the other hand, is nearly the same size as Earth, yet it became one of the most hostile places in the entire solar system. That shows that distance from a star is just one piece of a much larger puzzle. For a planet to sustain an Earth-like environment, several factors need to work together. An atmosphere of the right thickness helps regulate temperature and shields the surface from radiation. A magnetic field can prevent stellar wind from stripping away the atmosphere over billions of years. Ongoing geological activity can also be essential. recycling key chemical elements and helping keep the climate relatively stable. The problem is, we still don't know whether Kepler 452b has any of these characteristics. Its enormous distance rules out detailed observation, and much of this information remains completely beyond the reach of current technology. Even so, the future looks promising. Increasingly advanced telescopes are now allowing scientists to study exoplanet atmospheres with a level of precision that was unthinkable just a few years ago. Researchers look for molecules called biosignatures, substances that could point to biological processes like oxygen, methane, or chemical combinations that are hard to explain through natural phenomena alone. Detecting something like that on a planet such as Kepler 452b would be one of the greatest discoveries in human history. But for now, this world continues to keep its secrets. Maybe Kepler 452b is covered in oceans, where life has had billions of years to quietly evolve. Maybe it's a rocky desert, baked by a star that aged faster than we imagined. Or maybe it's something entirely different from anything we've been able to picture. The answer remains hidden more than 100 light years from Earth. And it's precisely that mystery that makes this planet one of the greatest symbols of the search for life beyond our own world. For nearly all of human history, we believed Earth might be a unique place in the universe, a small cosmic accident, impossible to repeat. But as our telescopes have grown more powerful, we've started to discover a far more surprising reality. There are now thousands of known exoplanets, and among them are worlds that challenge our imagination. Kepler 452b is one of the most fascinating because, for the first time, we found a planet that combines several traits we've always dreamed of finding in a potential second home. And yet, science also teaches us humility. Despite all the excitement, we still know remarkably little about this world. We don't know its atmosphere, we don't know whether it has oceans, continents, or a magnetic field, and we certainly don't know whether any form of life has ever emerged on its surface. Maybe it's a lush planet covered in seas and clouds. Maybe it's a hot, dry world, reshaped by the slow aging of its star. Or maybe it hides a reality completely different from anything we've imagined from here on Earth. Still, there's another detail that makes this story even more remarkable. Everything we've learned about Kepler 452b was discovered without ever visiting it, just by observing tiny variations in the light of a star more than 100 light years away. Humanity was able to calculate its orbit, estimate its size, understand its position within the habitable zone, and form hypotheses about what its surface might look like. That shows just how far human curiosity has already come, not through giant rockets or interstellar travel, but through science, mathematics, and an enormous desire to understand the universe. We may never walk on this planet. Kepler 452b may forever remain a tiny, distant point lost in the vastness of the Milky Way, but that doesn't diminish its importance. Quite the opposite. Every discovery like this reminds us that our solar system is just one among billions scattered across the galaxy, and that Earth may not be the only island of life in an apparently endless cosmic ocean. While Kepler 452b stands as one of the most promising candidates for a second Earth, there are several objects within our own solar system that challenge science in a very different way. Worlds where reality itself seems to have come straight out of a science fiction film. And that's exactly where we're headed in our next video. There, we'll meet some bizarre objects that exist beyond Pluto, look at the real possibility of life on Europa, and examine the strange changes currently taking place on Jupiter, the largest planet in our solar system. To check it out, just click the video appearing on your screen right now.